Okay, we're going to talk about implicit differentiation, differentiables. This is when you cannot solve an equation explicitly for y, or in other words, when you can't rewrite into a y equals equation. So our example is going to be, we'll write it over here so we have more room, x to the third plus y to the third equals 6x times y. So as you can see, we can't write this into a y equals equation. So an important note to make when you do this is to make sure you pay attention to all the different derivative rules. We'll use several different ones. Our first step is to take the derivative. So we're going to do this, and every time you take a derivative of y, you have to put in a dy dx. So we're going to use our power rule, and you're going to have 3x squared plus 3y squared dy dx equals, and this right here, we're going to have to use the product rule. So we have our f prime, which is 6 times g, which is y, plus g prime, which is dy dx times f, so 6x. Now we're going to move anything with a dy dx to the left of the equal sign. So you have 3y squared dy dx minus, because we're going to have to subtract this, 6x dy dx equals 6y minus 3x squared. Okay, now we're going to factor out our dy dx. And that's just going to make it 3y squared minus 6x equals 6y minus 3x squared. Now we have to isolate the dy dx. So we're going to divide all of this by 3y squared minus 6x. So these are going to cancel, and you're going to have dy over dx. Well, they're going to cancel, and you still have 3y squared over here. So it's going to turn into 6y minus 3x squared over 3y squared minus 6x. Now you just simplify, and that comes down to 2y minus x squared over y squared minus 2x. Here we go.